Hi, it's Mr. Crane here. I have been getting a lot of feedback on Magnet Lesson 3 and Electromagnet Lesson 1 and 2. So I'm going to do a couple of videos to help you virtual students be successful on it without the need for a magnet, without the need for a compass, without the need for electromagnets. So that's what we're going to do today is go over Magnet Lesson 3, and then I'll make a new video for Electromagnet 1 and 2. All right? So let's get started. So what I have done is I've taken the Word document in Magnet Lesson 1, I'm sorry, 3, Magnet Lesson 3, and I've converted it into a Google Documents. And you guys can do that by taking your Word document, go up to here, and then make a copy, or make it save as a Google Doc. I think that's what it is. Um, I could actually see. So if you come up to your Word file and you go up to here, it will say, for you, it will say save as a Google Doc. That's a little different than what mine shows. All right. So this thing, I don't want you to have to draw everything. I do want you to know that you can draw everything. But the first question says, what did you observe when you sprinkled iron filings over paper covering the bar magnet? Draw what you saw. So I have made a video a couple of years ago, and if you watch the video, you can see when I sprinkle iron filings over a magnet what it does. It's going to create an image that looks a lot like this. So here is a 2-bar magnets. If you see, there's a north, and we know that opposites attract and likes repel. So here is, you can see the fields. They're starting to, all the dipoles, all of the domains are starting to line up and show a field line, or a field of influence going this way. And remember, when we draw our field lines, they go from the north to the south. But right here in the center, they're pushing each other away. So the dipoles are not aligned right here. They oppose each other, and the force pushes the two magnets apart. So that is contrary to two poles like this, where they are attracting now. So we still have the same fields of influence out here, same fields of influence out here, but right there we have iron filings that have started to go towards each other and actually make connections, and all those little domains inside these iron filings are lining up and sticking together and making straight little pieces. So could I take that particular image and put it into my document? I can. So if you guys will use you have a button on yours that is up at the top where your F1 through F12 buttons are, and it looks like a little tiny square. If you use Control Shift and that button, it will make your screen go dark. I'll do mine here for my Windows. It's the Windows button, Shift and S, but it makes my screen go dark, and then I can actually take this image like that and capture that picture. And when I come into here, I select where I want my image to be, and I add that image into that space, just like that. So I know I didn't draw it, but um, that's how I can add that image there. I can come back to, so I'm going to actually put that. Can you explain how the iron filings, but why they behave that way? Do they look like the same patterns? Draw what you expect to see when we do too. So that's the next questions. So this is a real image right here. I'll put that back like that. But over here, you have another picture. You have some, if you were actually drawing these things, then you could see that this is what it might look like with iron filing sprinkled over a actual, let's go right there. So we have iron filing sprinkled over a single magnet. We don't know if this is a north or a south, but this is iron filings and the way that they've attached around this particular magnet. And you can see those field of influences, and then where they group together is where the magnetic field is the strongest. Okay? So let's go to the next question real quick. Move right along. So the next question is, can you explain why the iron filings behave that way? Well, I think we just did. We just explained that the domains align and they start to attach themselves to one another, and they create a field of influence from going from the north to the south. All right, so I did that. Do you see the pattern, or do you see the same pattern as you did when you did the compass tracing? So let's look over at a compass tracing. So inside the assignment titled Electromagnet Lesson 1 Replay, it's on November the 12th date, I put a link right here for this simulator. If you click on this simulator right here, it's going to take you right over to here, and you have a bar magnet and you have an electromagnet. All right, so if I take this, do I see my fields? If you look at these domains right here, these tiny little plus and minus arrows, the red and white arrow tips, do they look just like they do in this image right here? We'll look at this image right here and make it an actual magnet. So does this image right here, all of these images, do they look the same as this PFET simulator image where you see I have them, I have some groupings around the North Pole, some groupings around the South Pole, and I have an arc around the middle. We'll go back to that image. We do, right? So we see that same thing. So we could say, yes, they do have the same patterns. And draw what you expect to see when you sprinkle iron filings over 2 bar magnets, all right? So let's look at 2 bar magnets. So I can go back, instead of saying a single, I'll say 2 right here, 2 bar magnets. Pull that image up. And now I have 2 bar magnets. Let's see what we got. All right, so let's look at this one. This is a good one. So I'm gonna move my picture over a little bit. All right, so two bar magnets, and we're facing this away. If we notice that there is some attraction here and the lines are connecting, so we know that those are opposites right there. Otherwise, it'd be a clear space in here. But the arcs are the same. I have for my north to my south directions, whichever one is the north, whichever is the south. I mean, these could be 2 souths, these could be 2 norths. Sorry, could be 2 norths. So here's a 2 norths on 2 magnets right there. So we see a space right here that is given free, and I'll pull this one here up. This is a really good one. So see that? So we know that those are 2 of the opposites. Could be 2 north or 2 south right there. And it's an open space right there. So that's kind of great. Kind of gives us what we expect to see. All right, so in different alignments. So you can pick up whichever one you want right here. I want to pull this one up because this is what the class was doing. And I'm going to copy that image right there. I'm going to go and put that image, move my screen back again. So do you see the same pattern? We said yes, draw what you expect to see when you sprinkle the iron filings over 2 bar magnets. So this is what we expect to see. We expect to see this, right? That's what we expect to see. I guess we say what we in fact saw, and then what we expected to see would be a different picture, because this would be assuming that we drew it. So if we drew something like this, this is what we would expect to see when we drew it, right? Did not mean to open that up. Oh, my bad. So let's get rid of that magnetism thing. Come over to this and hit copy. Go back to the assignment. Put that in here. Put that in there. So now that's what I expect to see over this area. I have a gap, and then I have connected areas, and then we have that same thing here. All right, so that should take you through this particular lesson. If you listen to my words, rewind it, you can get your answers for 2 and 3. Google's your friend. In this world that we live in today, where you might not have access to compasses, or you might not have access to magnets, then we do use alternative sources. But I do want you to understand what you are seeing. Okay? Hope that helps, and have a great day. Bye. See you on Electromagnet 1.